These are the answers to the quiz that we took today, the 19th. So the first thing is, what's the formula for the self-ionization of water? And this is it's a reversible reaction. So we have two reagents. Both of them are water. H2O plus H2O. These are both in liquid form. You cannot have water in aqueous solution. Water is the aqueous solution. If you show H2O aqueous, that's wrong. And that ionizes to form hydronium. Now the hydronium ion is an aqueous solution. And hydroxide, also in aqueous solution. If we put brackets around those ions, then we're suddenly talking about their concentration. We don't want to do that. We just want to leave it as ions, just like any other ionization or dissociation equation that we would want to write. For number 2, what's the concentration of hydronium ions in 1 liter of pure water? We have 1.0 times 10 to the negative 7th. And you can say either moles per liter is equal to the concentration of hydronium ions, or you can say 1.0 times 10 to the negative 7th molar equals the concentration of hydronium ions. Because anytime you put that H3O1 plus in brackets, you're saying concentration of hydronium ions. Okay, so number 3. In a liter of water, how does the concentration of hydroxide ions compare to the concentration of hydronium? They're equal. They are equal, and if you want to think about why, we recall that in a whole liter full of little water molecules, in order for this one to get a third ear, the other one had to give it up. So if you have pure water, in order for there to be a hydronium, there has to be a hydroxide someplace. What I wrote on my key is every H3O1 plus that has an extra proton had to get it from another water, forming a hydroxide ion. So that's that one. Okay, number 4, a solution with a concentration of hydronium ions greater than the concentration of hydronium ions of pure water, we would call that an acidic solution. The substance is an acid, the solution is an acidic solution. And a solution with a hydroxide ion concentration greater than that of pure water, we would call that a basic solution, or a base would be the substance. You can also say alkaline for the solution, which is formed from taking a base and putting it into aqueous solution. For number 6, 7, and 8, these are just testing you on your use of scientific notation. So 1 times 10 to the negative 12th is less than 1 times 10 to the negative 7th. 1 times 10 to the negative 4th is greater than 1 times 10 to the negative 10th. And 1.0 times 10 to the negative 7th is less than 1.0 times 10 to the negative 2nd. Pretty easy. Okay, so 9, 10, and 11, a solution with a hydroxide ion concentration of 1.0 times 10 to the negative 3rd, that's greater than the hydroxide concentration of pure water. That's going to be a basic solution, or the substance would be a base. It would be an alkaline solution or a basic solution. Number 10, a solution with a hydronium ion concentration of 1.0 times 10 to the negative 6th. That's greater than the hydronium ion concentration of pure water. That's going to be an acidic solution. The substance that you've got in solution there is an acid. And number 11, a solution where hydronium and hydroxide ion concentrations are equal, that is neutral. That is a neutral solution. When you have equal numbers of hydronium and hydroxide, that is equal. Questions, comments, concerns?